At National 5 level, the skill of expanding a pair of brackets is typically taken a bit further than just two linear expressions within the brackets. One of the brackets usually contains some sort of quadratic, and we're looking at how we can expand that combined with a linear bracket. That's the skill we're going to discuss here. How we can combine a quadratic and a linear bracket combination to expand them. So putting it simply, the question is how can we expand a pair of brackets involving a quadratic element? There's two methods I'm going to demonstrate for you here. Now again, I want to emphasize that these are not exhaustive. These are two methods I'm going to show you that I work with. If you know of a different method that works effectively for you and gets you the solution, great, stick with it. However, feel free to look at these two methods and think which one works best for you. Now the first method, what I'm going to do is I'm actually going to expand around the first bracket. I'm going to focus on that to begin with, because what I'm going to do is I'm going to take this one expansion involving a linear function with two elements, and I'm going to use that linear function to turn it into two simple singular bracket expansions. And what I mean by that is I'm going to look at each part, the x and the plus 1 in this case, and I'm going to say I'm going to expand the quadratic bracket using each part of that. And what I mean by that is I'm going to split it and I'm going to say fine, so the first element's the x, so I'm going to expand the x with the x squared plus x plus 3, the quadratic element. The second part is a plus 1, so I'm then going to do plus 1, expanding by the brackets x squared plus x plus 3. Now with this method, one thing that's key that you need to look at is the sign in the middle of that first bracket. Let's say that were x minus 1. My second part here would be minus 1 times the quadratic bracket. This allows me to expand around that and work with the signs effectively in this manner so that I'm working with them and simplifying them as I go through the expression in the expansion. So if I were to then expand the brackets, I've got to remember each element within the bracket gets multiplied by the element outside. So I do x times x squared, which gives me x cubed, x times x, which will give me plus x squared, and then x times 3, which will give me plus 3x. This is the first part expanded. I then do plus 1 times that entire bracket. Well, if you multiply anything by 1, you're going to end up with the same thing. So actually, that'll just end up giving me a plus x squared plus an x plus a 3. So it'll end up giving it to me in that manner there. And what I then do is what I always do at this stage, I simplify. Now the x cubed is going to stay on its own. I'm going to gather together all the x squareds. So I'm going to end up with plus 2x squared. I've then got all my x elements, so a 3x and an x. That'll give me a plus 4x, and then I'll end up with a plus 3 on the end on this one. So I can expand it using that way. I can split the first bracket up, do each quadratic expansion on its own, combine the whole spiel together at the end. The second method we can do is we can go back to our old faithful method, which is to use a table. Now if I were to do this one, what I would always recommend is that you make the column at the start the linear bracket. So I have an x and a plus 1. Then when I split up into my columns here, I'd use my quadratic across the top. My first column would contain the x squared, my second column would contain the plus x, and my third column would contain the plus 3. So as you work along, you go down in powers with the quadratic term, your linear term, and then your constant term there. And remember taking the pluses in with it. If these were negatives, I'd take the minuses in. Then the elements still get filled in the same way. Product of row and column together. So the first box here would be x times x squared, which gives me x cubed. I've then got plus x times x, which gives me plus x squared. X times plus 3, which gives me plus 3x. Move to the second row, I get plus 1 times x squared, so I get plus x squared. And I get plus 1 times plus x, which gives me plus x. And then plus 1 times plus 3, which just gives me plus 3. And you'll notice that every single element in that table is the exact same as the elements there, which means I can then simplify. A cheap way of simplifying actually at this stage as well, saving you writing it all out, is if you look diagonally, you'll notice that the powers match up here. So I could say, for example, this first diagonal is a plus x squared and a plus x squared, which simplifies to plus 2x squared. Second diagonal here, I've got a plus x and a plus 3x, which will give me plus 4x. So I can then simplify the whole thing x cubed plus 2x squared plus 4x plus a 3. So if they're all within the same variable, that's actually a little quick cheeky method you can recognise at that point to help you as part of your simplification. If you write everything out and then simplify it, no issues at all. Some people might notice this cheeky bit method, and that's fine. Stick with it if it works. Show you another example, and again, I'll demonstrate both methods to you. First method is to split it up using the linear bracket. So I'd split that up into 2x times the quadratic bracket, so 2x bracket 2x squared minus x plus 1. And I then split it up again. Now I've got a minus 1 there, so it's going to be minus 1 times the bracket. 2x squared minus x plus 1. We can then expand each of these on their own, simplify everything together. So that first bracket would become 2x times 2x squared, so I've got 4x cubed, 2x times minus x minus 2x squared. I've then got plus 2x. Second bracket is times by minus 1. Essentially that means flip the signs of everything. So minus 1 times 2x squared is minus 2x squared. Minus 1 times minus x is plus x. Minus 1 times plus 1 is minus 1. Then it's gather and simplify. So find 4x cubed minus 2x squared is minus 4x squared. Plus 2x plus x is plus 3x, and then my minus 1 there at the end. So there we go. Expanding it using the linear bracket and splitting that, that's how we do it. The second method was the table. And again, similar setup as before. My recommendation, make the first column the 2x minus 1, the linear bracket. If you didn't and you made the first row the linear bracket, so your quadratic was going down in that column, you'd still be fine. You would just end up with your table going down the page instead of across the page in this manner. You'd have no issues whatsoever though if you did that. So the first row would be my quadratic. 2x squared minus x plus 1. Filling in the table, same as we've done every single time. Each element, product of rows and columns. So I'd end up with 4x cubed minus 2x squared plus 2x. Now my second row will become minus 2x squared plus x minus 1. And again, if you notice it, because it's the same variable throughout, my two diagonals here can be simplified. Minus 2x squared gives me minus 4x squared, plus x plus 2x gives me plus 3x. Then we can write the whole thing out. I've got 4x cubed minus 4x squared plus 3x minus 1, which is the exact same as what we got before. So two different methods for solving the exact same thing. Again, pick the one that works for you. There is no one correct method for this. They all work. Make sure you pick the right one that's suitable for you. So I'm going to put up two examples, pause and have a crack, and then come back and check, and I'll show you both methods and how they work out for both examples. So let's look at how we do each of these on their own. So we'll split it first and do the linear split. So if I was to do that, I'd split this linear bracket. 4x is the first part, so it would be 4x bracket 2x squared plus 2x plus 3. And then the second part's a plus 1. So it would be plus 1 times the second bracket, which is 2x squared plus 2x plus 3. Then expand each on their own and simplify. So the first bracket would expand, it would give me 8x cubed plus 8x plus 12x. I'd then have plus 2x squared plus a 2x plus a 3. The whole bracket is just multiplied by 1. Then we'd gather each of our terms together. So I'd have 8x cubed. I've got plus 8x squared plus a 2x squared. So I'd have plus 10x squared. I then got a plus 12x and a plus 2x, which are going to be plus 14x. And then my plus 3 at the end there. So there you go. That's what it would be using that expansion method. I could, again, use the table if I wanted. So let's make the first column the linear bracket. So I've got my 4x and I've got a plus 1. My first row would then be the quadratic. So I've got 2x squared plus 2x plus 3. And then it's the entries. Each entry, remember, product of row and column, as it always has been. So it'll be 8x cubed plus 8x squared plus 12x. Second row would then be plus 2x squared plus 2x plus 3. And again, it's unnoticed. There's my diagonals. Simplify them here. Plus 2x squared plus 8x squared gives me plus 10x squared. Plus 2x plus 12x gives me plus 14x. And it lets me write out my whole final solution, which is 8x cubed plus 10x squared plus 14x plus 3. And again, lo and behold, exact same solution. Both methods, same solution either way. That's what we're after. The second example was this one here, 3x minus 4, dx squared minus x minus 4. Again, let's demonstrate both methods. So the first one, let's split up the linear factor and then expand around the quadratic. So I'd have 3x, bracket the x squared, minus x minus 4. And it's a minus 4 there, so it's going to be minus 4 times the bracket. So the x squared minus x minus 4. Expand each on their own, simplify everything together. That first bracket would then become 3x cubed minus 3x squared minus 12x when it's expanded. Second one would become minus 4x squared, then have plus 4x because of the negative negative, and then plus 16. Then it's simplifying. So I'd have 3x cubed, I've got minus 3x squared minus 4x squared, so that would then be minus 7x squared. I've then got minus 12x plus 4x, would give me minus 8x, and I've got a plus 16 at the end. So there's the first method, that's my solution. Second method was the table, and again, same setup, same steps as we've always done with the table. Column would be 3x and a minus 4 there. Top row would then split up and become our quadratic, so in this case it would be x squared minus x and a minus 4. Usual drill, each element, product of row and column. First one here becomes 3x cubed. I've then got minus 3x squared. Then got minus 12x here. Then turn to the next row, we get minus 4x squared plus 4x plus 16. Then our diagonal trick to be able to simplify up. So minus 4x squared minus 3x squared gives me the minus 7x squared. Plus 4x minus 12x gives me minus 8x. And that then lets me write out my final solution, which is 3x cubed minus 7x squared minus 8x plus 16. The answer, it's the exact same thing. Both methods work out. Both methods give me the same answer. I'm laughing. I've got a good choice. Now remember, these aren't exhaustive. These are the two methods I'm showing you. If you've got any other methods that you can use, feel free to use them with this sort of expansion. You should still get the same solutions presented here for both examples. So what are the rules when it comes to working with this? First and most importantly, determine the method you feel suits you best. That's a key thing. Remember, there's no one single dedicated method that works well and is correct for this. There are multiple. So expanding the brackets, I said, use the first bracket to split it up and watch the signs. The second method was ever faithful using the table. Just remember to take the signs into the table to aid with dealing with the signs in the calculations, as we've always done. When we expand them out, we have to simplify and gather like terms when needed. So when we've got the bracket and we expand using the linear one, we had to get together terms that way. When it was the table, look at your diagonal parts for simplifying. That made it nice and quick and simple at that point. Ensure the letters and constants all stick together appropriately. And the key thing at the end is always remember to sort your signs. They should be dealt with as we're going, but just double check them at the end and make 100% sure. Remember, this is a fairly straightforward set of steps once we get into the swing of it and once we get used to it. Just remember our ultimate goal. Think smart, solve fast.